Okay, so last night you had a question on this problem right here. And before we get into it, I'm going to go into it and do, step by step and talk everything through. But before we do that, let's look at these two problems. This will kind of inform our conversation here. So you tell me, so what can we, so the idea, right, with all of these, everything that we're doing right now is factor and cancel, or factor, we call it reduce it, like write it in reduced form.
Mm-hmm.
Right now, the question is this thing reduced?
Nope.
No. What can we do to it to reduce it?
You can factor out a 2 from the bottom.
Yeah, exactly, right? Because it's like, now, here's the thing, right? Like, let's just make this clear right now, that if I had something like this, we would be done. Because you can't just say, oh, the 2 cancels with the 4. You can't do that, right? Like, the only way to cancel something is if you have nothing but multiplications on the top. And let's go, how about D, A, and F, something like that. As long as it's multiplied by, then yes, as long as everything on the top is being multiplied by and everything on the bottom is being multiplied, then you could do something like this and cancel, and we're good to go. You can't do that if you have something like this, A, B, how about C, D, and then you have like an A and a Z. You can't say, oh, I could cancel this A because, well, no, you can't, because it's not in both of these guys. And I'm probably telling you something that you're very familiar with and that you already believe, but I just want to make that point, right? Like that in order to cancel something, it has that thing has to show up in every one of the terms in a sum or difference or something like that. So what you just said is factor out the 2 from the bottom. So I'm just going to rewrite the top. And so what does it look like when I factor out a 2? What am I left with?
X plus 1.
No. We're not taking one step at a time.
Sorry.
Yeah.
2x.
So there's a 2.
So you take the 2 and put it outside the parentheses.
There we go. Okay, so now, okay, so I factored out the 2. Now can I cancel out that 2?
Yes.
Yes, because we have multiplication on top, multiplication on the bottom, and so I can cancel out that 2, and I'm left with the 2x plus 1. Now, what you could have done, and I don't recommend doing this because I just don't, like, you could say, like, from right here, you say, well, wait a minute, there's a 2 in here, right? The 4 is just a 2 times 2. And this 2, I could just cancel, like, I could go straight from here and say, well, this guy cancels with the 4 and with the 2, and then jump straight to here. But, like, that's true, but as things get more complicated, that's going to, if we get in the habit of doing that, that's going to actually end up taking much longer and will probably end up screwing a bunch of things up. So it's better to take this intermediate step where you factor something out. That way, another thing, and I've said this over and over again, is every time you take a step where you're factoring something, take a second and check your work and say, well, wait a second, is this truly equal to that? And then what do you have to do, right? You have to take that 2 and distribute him back in. So every time I factor something, I take a second and then just redo what I have undone, right? So pull out a 2 and I go, wait a minute, did I write this correctly? Well, if the 2 jumps over and hits that, I get a 4x. Yes. The 2 jumps over and hits the 1, I get a 2 times 1 is 2. So that thing is the same thing as that. Okay, I feel good. So long story short, we have to factor something out of the bottom and then we get that guy. Okay. Next question. Is that guy reduced?
Yes.
This guy is reduced.
Sorry, wrong person. Oh my gosh. I am so out of it this morning.
You should be. Just finish physics. Like if you weren't out of it, I'd have your mom call the doctor because you should be out of it after physics. That's rough. So
You know it is not.
it's almost the same setup, almost, right? What do we have to do to reduce this guy?
Do the parentheses and take an X out.
There we go, right? So I'm going to rewrite the top without changing it. Now do parentheses, and you said pull out an X. So I write an X here.
Yes.
Okay, and then what's left in the parentheses?
X plus 1.
Plus 1. Now let's check it, right? I believe you. Let's check it. The X jumps over, hits the X, and then we have an X squared. Good. X jumps over, hits the 1, and we're left with an X. Okay, I buy it. Now, can we do any cancellations?
You can cancel out the X from the top.
Yep, here we go. We have that X on the top. We have that X on the bottom, and we're left with a Y over X plus 1. Okay, I'm gonna leave this one up because this one's gonna help in a minute. So one thing I didn't really talk about here is really the first thing that goes through my head when I see either of these questions. With the first one, I see a 2 times an X on the top. And I immediately think, well, if this thing is going to reduce, then we're going to need either a 2 or an X down in the denominator by itself, right? Like if I could cancel either the 2 or the X out, then I should be able to write it so that there's a 2 all by himself or possibly an X all by himself. And so that kind of informs my next step. Because like if there were a 7 up there, I wouldn't be thinking, oh, I could factor out a 2. That wouldn't help me, right? If I started off with 7x over 4x plus, who cares, 8, I wouldn't be thinking, oh, I could factor a 4 out of there. I'd be thinking, well, if anything's going to cancel, it has to either be a 7 or an X. I can't pull an X out of here because there's only one X. There's no 7s in there. That's 2 times 2, and that's 2 times 2 times 2. So I'm done. Like this guy is as reduced as it gets. But in this case, when I look at it, I think, well, if anything's going to cancel, it's either a 2 or an X. Can I get a 2? Oh, I can get a 2. I could pull a 2 out of here. That'll cancel the 2s and leave me with this. Same thing over here. I think the first thing I notice is, okay, I have an X times a Y. So if I could get an X or a Y all by his or herself on the bottom, then I could cancel one of them. Can I do that? Then I look at that and see, ooh, yeah. I can pull out an X. I could cancel those X's, and now I'm left with this. Now, just because that's what goes through my head doesn't mean that it's not a good practice to go ahead, and if you're given something like this, you might want to go ahead and factor it depending on what you're working on, right? Like I might go ahead and do something like this. And then once I've done that, I'm going to go, of course, check and say, yeah, the 4 jumps over, hits the X, 4X. 4 jumps over, hits the 2, 8. Yes, I'm good. Because, well, it depends on what I'm doing. In this case, in this context, the idea is we want to cancel stuff. And so anyway, I'm sorry, I'm just rambling. I'm just don't want us to get the idea that like we have to go down a certain train of thought every single time we do a problem. But this is, in this context, this is what goes through my head. And so given that that's the case, are we ready to move on to this guy?
Yes.
Okay, so what I just said was the context is we are trying to cancel things. We want to write this in reduced form. And so I want to cancel things. And so it's kind of the same thing. It's like, well, and then before anything happens, I notice that this is a difference of squares. That's the first thing that I notice. It just jumps right out at me. So I'm going to think, well, as it stands right now, I can't just cancel anything. I have to have a product at least on the top in order to cancel stuff, unless I happen to have, well, but anyway, right? And so that's what goes through my head. And so now I'm thinking, okay, well, why don't I rewrite the numerator as in its factored form? So I'm going to copy the denominator without changing it. To MT. What do I get when I factor the top?
M plus T times M minus T.
Oh, M plus T times M minus T. You should be able to do this in your sleep, right? Like I see a difference of squares, boom, that's what it is. So now this is what goes through my head. It's kind of like this. It's like, well, I have something, I'm hoping that something's going to cancel. And so my options are, if I could get an M plus T by itself on the bottom, then I could cancel it. Or if I get an M minus T by itself or factored out on the bottom, then I could cancel it. So then I start asking myself, well, do I have an M plus T or an M minus T? I do notice that there is an M plus T, but I can't just cancel him out because he's not multiplied by the whole thing. You know, it's, yeah. So I just start looking at it and I see, well, wait a second. M squared and T squared. We can't factor that because it's plus. It's not a difference of squares. But we have this 2MT, right? And so I'm thinking, well, if I put those together, and so I'm just going to go ahead and rewrite it. I'm still at this point not sure of what's going to happen, but I'm hopeful that maybe if I rewrite this, how about like this, 2MT plus T squared plus M plus T, then maybe something jumps out at me. And the whole reason I was doing that, because I've seen about 1,000 of these. And that's why I noticed that, hey, these guys are somehow related, right? This M squared and the T squared and the 2MT. If I could get those together, then now, what can I do? In fact, what is that right there? Can that be factored?
Yes.
Into what?
MT times MT.
Well, yeah, there you go. Wait, MT times MT.
M plus T times
M
M plus T.
plus T times M plus T, right? Because I noticed that that is a perfect square. In other words, what I'm saying is M plus T squared multiplied by itself is equal to M squared plus 2MT plus T squared, which is the same thing as M plus T times M plus T. And we could double check. The first gives me M squared. The last gives me T squared. The outer gives me MT. The inner gives me MT. Add those together, we get 2MTs. Okay, so that's what I'm going to do. I'm going to rewrite this as M plus T times M plus T right there. I haven't changed anything else. Now here's the problem. That at this point, we can't just say, oh, here's this one, I'm going to cancel that one. Because, well, we're in this situation. And what actually helps at this point is to say, well, hold up. Let's kind of group these guys together. I like to literally write this out so I could see it visually now. And if you'll notice, this thing is actually this thing. All I've done here, I went ahead and set this up ahead of time, is I'm saying that, well, if you think about this, M plus T, if you think about that as X, And if we think of this m minus t, well, it's not the same thing. Those are two different things. Let's just call it y. That m plus t, we just called it x, so I could call it x. That m plus t is an x, I could just call it x, plus another one of them. That is the same thing as that right there. It's just, the way we chose to write it was m plus t times m plus t. We could have written it, instead of writing it as m plus t times m plus t, we could have written it as m plus t squared. Either way, it's not going to matter. In order to cancel that x right there, we had to factor out an x from there. So we're going to have to do the same thing here, right? And that's what we're doing right now. So in fact, I'm gonna rewrite this exactly right here, because I don't want to have to make a big jump. I want to see it right beneath what I'm doing. So I'm just going to copy this down. Right now we're at m plus t times m minus t all over. And the way we've written it was m plus t times m plus t plus m plus t. Okay. Now, again, right, if you were in this situation, you could say, well, one of the x's cancels with one of those x's, that x cancels that x, but we don't like to do it that way. We'd much rather factor one of these guys out. So let's do that. The top stays the same, m plus t, m minus t. And now, I'm about to factor out, let's choose a couple of them. I'm going to take this guy right here, pull him out. I'm going to have to take him out as well. That's going to leave me with something that looks like this. And what are we factoring out? The m plus t. Why don't I go ahead and write him like this? And so now what's left in here? Let's think about it this way, right? Well, there's going to be a plus in between them, right? Here you have that times that. You factored one of them out. It's the same thing. It's actually the same thing we did earlier when we had 4x plus 2. Just kind of forget the x's there, right? What we have is 2 times 2 plus 2. And what we did is we factored out one of the 2's from each one of these. And what we were left with was a 2. One of the 2's stayed put, and we were left with a 1 like that. Same thing is happening here, right? We have an x times an x plus x. That's all that means, right? X squared means x times x. Plus x is plus x. And then what did we do? Well, we took one of them and pulled it out, putting an x out here. What was left? Well, that guy got left over. And then, well, I guess we have a 1 left over from that. And we could double check that when you multiply this back through, you get x times x, and then plus an x. So it's the same kind of thing happening here. Pull out one of those MTs from this first thing, and what's left over is 1 m plus t, like that. Pull out an m plus t from the second thing, and what's left over but a 1 right there. So that is now factored. Now, remember what I do, right? I take a step like this, and I like to double check it. And so I do that in my head, but let's be really explicit about this right here, right? So we have this has to jump over and hit that, and then hit that. When it jumps over and hits that, we get m plus t, which is that guy, times that guy, which is an m plus t. Then he jumps over the plus sign, hits the 1, and I get an m plus t, like that. And then I could see that that thing is the same thing as that, which is that right there. Does that make sense?
Yes.
That was, I wrote that in the last night when you were having problems with this, and I wrote that out to you. This is what I did right here. And you were like, where did the other one go? There were two of them. Well, yeah, I factored, yes, there were two. The same way there were, well, there's technically right here, there are 3 x's, right? That means x times x plus x. Same thing as this, there's an x times an x plus an x. And I factor one of them out because we have a common factor here. That leaves me one of them, but then that guy's gone and he ends up on the outside. Same thing's happening here. If I notice, oh, there's a factor there and a factor there, just like this, right? There's 2 of them. And then there's only one of them. Well, there is one common to both of them. There's one x in each one of those at least. And then so we could pull that one out, and that's what I've done right here. Pull that one guy out, but that removes him completely the same way it removes this guy completely. Since there were 2 here, when I pull one of them out, it leaves one of them right there. So that's what we've done. That's why that works. Now, and indeed, this is the exact same thing as this, right? These guys are exactly the same. I've just said, let m plus t equal x. Let m minus t equal y.
Oh.
They are exactly the same thing. You have 2 different things multiplied by each other. You have this thing and this thing and this thing, which are all the same. It's just x times x, which is x squared, plus x, which is that guy right there. And so given when it looks like this, it's obvious, well, you just factor out an x. So you factor out an x, and this is what you're left with. But over here, it's not easy to see because now instead of it being x, it's m plus t. But these are all the same sort of things. In fact, what we could have done, another way we could have written this is we could have jumped right from here to say, well, that is m plus t squared. And now it's even easier to see that that thing is exactly the same as this thing. It's just instead of calling it m plus t, we're calling it x. Instead of calling it m minus t, we're calling it y. And now we have x squared plus x from the bottom. And we'd say, well, to cancel that guy out from that guy, we would need to pull one of them out. And when you do that, guess what you get? The exact same thing right here. Parentheses are your best friends in this case. And it starts to look really ugly because now you have parentheses in parentheses and parentheses on the outside of parentheses. But this is what you're doing. The same principle applies. And just one more time, I'm going to double check that when I multiply him back in, the same way that I do here, right? Once I've taken this step, I stop and go, well, wait a minute. The x jumps over and hits the x to give me an x squared. Yes. The x jumps over and hits the 1 to give me just an x. Yes. Okay, so that and that are the same thing. I'm going to do the same thing here and say, well, this jumps over the big parentheses to hit him, which give me m plus t times m plus t. Yep, that's that. Then he jumps over the big parentheses, over the plus sign to hit the 1 to give me that guy right there. Yes, this is the same thing as that. Tracking?
Yeah.
Cool. Now we could do our cancellation the same way that we did right here. We said, well, hold up. Now we have multiplication. We have multiplications on the top. We have multiplications on the bottom. And so everything that's on the very outside of those multiplications, we can now cancel. And so I'm going to say that m plus t cancels that m plus t right there. Now I am left with, on the top, m minus t all over m plus t plus 1. And those were in my big parentheses, but now I could just drop those big parentheses. And now I could actually drop those parentheses too, if I wanted to. I mean, we're technically done. This is good enough. But if I wanted, I don't know why I may or may not want to do this. Just rewrite it as m plus t plus 1. Either one of those are perfectly good. That is what we're doing. Does that shine some light on the problem? Cool, cool. Yeah, I know. And like, as I was writing this, I'm like, man, this is hard to explain unless I could like sit here and like talk about it. And I love this jump right here. And what honestly, like when these things get really, really ugly, sometimes it's nice to just like on some scratch paper or just beside, like as you're doing your work, go, wait a second, whoa, I'm jumbled. I don't really know what's happening. But I could tell that this is the same kind of beast as that, which is the same thing as that, which is the same thing as that. That's a different kind of beast. That doesn't mean the exact same thing. But these all mean exactly the same thing. So why don't I just call that thing X? Okay, that's a different thing. So I'll call it something else. How about Y? Okay, Y. Now what about this? Well, that's an X and an X. Oh yeah, X squared. Okay, plus, oh, that's still the same thing. That's an X. And then kind of get out of this land for a second and work with the problem. What did I say math is? It's the art of taking things you haven't seen before and turning it into things you've seen before. It's kind of what I'm doing right here. And sometimes, you know, usually though, like after you've done 2 or 3 of these, you'll get in the hang of it. But until you get the hang of it, sometimes it's nice to just say, well, wait a second, how would I solve this problem if it were an easier type problem? Well, this is what I would do, and this is what I would do. So maybe by analogy, I'll kind of do the same thing and see what happens. And then, yeah, I could see that that would be the same thing as that. And then that would cancel, and I'd be left with that, which is the same thing as that. And so, okay, are we good? Do you feel good about this one?
Yes.
Cool, good. So, let's talk about the quiz. So you have a quiz next time. Can I erase all this stuff?
Yes.
Okay. So you have a quiz. It is 7 problems. I have written it up and I've written up solutions for it. There are 7 problems. The first problem, I give you an expression and I say to write this in standard form. And I'm very pedantic about it. Like I've written, I even say, i.e., that means write it as a polynomial in the form a(n) x to the n plus a(n minus 1 x to the n minus 1 plus. And I have this actually written on there. And I just want to talk about this for just a second. And I say to write it in a polynomial as a polynomial in this form. And normally I wouldn't even go into what I'm about to say, but I've taken plenty of quizzes and exams in my time. And I know that when you have a timed quiz in front of you, all reason and sense goes right out of your brain and you start going, wait, hold up. What? So I want to go ahead and address this right now so that you don't freak out when you read what I wrote and then, and so on and so forth. So let's just do this. So a polynomial in standard form. Let's look at this. How about 3x cubed? How about minus x? How about plus 2? Is this a polynomial in standard form?
Yes.
Yes, it is. That's the correct answer. So if you do your thing and you end up with something like this, that is what I'm looking for. What I'm not looking for is this, that you go, oh wait, but he said it needs to look like this. Well, okay, then it needs to look like this. Plus x. Because, right, like I don't want you to get hung up on this and be like, well, he said standard form, and so I need to show what each one of these things are. And so since the x squared term doesn't show up, I need a 0. Oh, and it says that it has to be a plus in front of there. So how about a plus and then that's a -1? And no, that's not what I'm looking for. All I want is you're going to get some answer, and I just want it written like this so that you have, that's all I'm trying to say. And after writing that in there, I was like, man, I'm just going to take that out. And then I thought, no, we'll just talk about it before the quiz. And so that's all I mean, is that you have some polynomial and just write it in descending order. You don't need to account if there happens to be any terms missing. You don't need to rewrite it as plus a -1x or anything like that. Just that's what I'm looking for. Okay. So there's that. Now, you will need to be very familiar. I'm going to say you need to know differences of squares. You will need to know sums and differences of cubes. That is, if I gave you something like, if you see something like x squared minus y squared, just like we had earlier, that m squared minus t squared or whatever it was that we were just working on, like we could immediately say, hey, that thing right there is x plus y times x minus y. Ditto with cubes, right? You'll need to recognize that if you have, I mean, the same thing I'm talking about, right? If you see something like a cubed plus b cubed, you will need to say, oh, I know how to do that. That's a plus b, a squared opposite sign minus ab plus b squared, right? Okay, that should be obvious. Like that was pretty much half the chapter, is recognizing this guy, these guys. So I really didn't even need to write this. You should know, you should expect that that's coming up. Now, one thing that I do say, and it's, so there's question number 1. Let me just double check this. Question number 1 has that thing about writing something in standard form. Questions 2, 3, 4, 5, and 6 all say factor this thing completely. So more than half your quiz is just factor completely. Now, one thing I want to talk about, and in fact, I want you to do this. I want you to tell me what to do. Okay, let's say that I have something like this. How about x to the 4th minus y to the 4th? Is that factored completely?
No.
What do I need to do?
You need to have your x plus, well, you have to do the thing with the exponents and the parentheses so that you have x squared.
Okay. You said have x squared?
Well, no, wait, hold on.
No, yeah, tell me what to write.
Well, when you have x minus y in the, wait, hold on.
Wait a second. Okay, so x to the 4th minus y to the 4th. Tell me what to do.
You would have, wait, hold on.
Okay,
Yeah,
it doesn't need to be in your head. Just start, like, just go ahead and take a second, like write this out as though you were doing this problem right now, and then take a second. I'll have some coffee. In fact, I'm gonna take just a minute, and then we'll come back, and then you tell me what's.
Okay.
Okay.
I'm not sure if this is right.
Okay.
Would you have like two parentheses and then you'd have x plus y squared, and another parenthesis you'd have x minus y squared?
So
Or
did you say x plus y squared?
yeah.
Not quite, because what is that? That's x squared plus 2xy plus y squared. And this would be x minus y squared would be x squared minus 2xy plus y squared. That's not quite what that is. Now, what I notice is that this is a difference of squares.
Mm-hmm.
The way I like to do it, like we could just jump straight to the chase, but what I like to do is rewrite it as actually a difference of squares. That is raised to the second power. So how could I write x to the fourth as something raised to the second power?
X squared.
Exactly. And if you're not sure about that, if you like, let's say that you're doing this and you write that down and you go, wait a second, is that true? Just take a second and go, wait a minute, well, let's just check it. I've just proclaimed that that's true. We could go either way on this. We could say, well, let's do the inside first. And I'm going to say x squared is the same thing as x times x, then squared. Okay, so I have x times x squared. Well, that means take whatever is in your parentheses and multiply it by itself. That's what squared means. So I'm going to say, okay, well, that means x times x times x times x, which is 1, 2, 3, 4 x's. We could rewrite that as x to the fourth. Now, another way we could have done that is we just say, well, hold up. Let's do the outside part first. Well, squared means to take it and multiply it by itself. So that means x squared times x squared. And then x squared times x squared. Well, it's the same thing. It's x times x times x times x. And so if I multiply x squared times x squared, I get x to the fourth. And so, yes, I feel confident then that that works right there.
Mm-hmm.
So what about the second part?
You have y squared.
You would have y squared squared. Okay. Now, this is a difference of squares. So what do I write?
X. Yeah, we have two parentheses.
Two parentheses. Yes, thank you. Thank you. That's what I was looking for. We have two parentheses. And what goes in for here and here?
X squared and y squared.
Okay, so x squared, y squared. What about in here and here?
X squared, y squared.
Squared, y squared. And now what?
Plus and minus.
Plus and minus. Okay, now, of course, anytime I do a factor, I check it, right? And so I'm going to do that. I'm going to go first, outer, inner, last. My first gives me x squared times x squared, which is x to the fourth. My outer gives me x squared minus y squared. So that gives me minus x squared y squared. My inner gives me plus x squared y squared. So plus x squared y squared. My last gives me y squared and y squared, but it's minus. So I get a minus y squared and y squared is a total of 4 y's. And so it's to the fourth. The outer and the inner cancel. And I'm left with x to the fourth minus y to the fourth. And that is where I started off. Okay, so I feel good about this. I believe that we have correctly factored that guy. Now, here's the question. Is this factored completely?
No.
No. What do I need to do?
Would you factor each one separately, right?
Well,
Or you
can we factor the sum of two squares?
no.
Not without complex numbers, and we are not dealing with complex numbers. So remember what I said, that what we're going to need to know, and I even put know, like you must have intimate knowledge of, are differences of squares. That is, if you see a difference of squares, you should be able to look at it and go, that's a difference of squares. I know that there is a formula for that, or I know how to break that guy apart. You will need to know sums and differences of cubes. That is, if you have something to the third power plus something to the third power, then you can manipulate that guy and break him apart. But sums of squares are done. As soon as you see a sum of squares, it is done. You do not need to worry about a sum of squares. A difference of squares, though, we should be able to break apart. That is, we should be able to factor a difference of squares. Do I have a difference of squares in this expression?
Yes.
All right. So what do I write?
Well, you have to keep the sum first, right? So x squared plus y squared.
Oh, yep, that has not changed. And he is completely factored. Nothing more we could do there. Well, what about this guy? Now what do I write?
You can take okay, you have your big parentheses. And then you take x. Wait, what?
I don't know. What do I write?
Well, don't you have your bigger parentheses? Oh no, I'm looking at the wrong thing. Sorry.
Yeah. Square root.
You can have your two parentheses. You do the x on the first side and on the second side, and then you have your y's. And you have a plus and a minus.
Plus and a minus. Now are we factored completely?
Yes.
Yes, we are, because we cannot do anything with a sum of squares. These are prime. They have no common factors. There's nothing we could do there. Okay. Now, so this is something I just wanted to talk about, because from parts question 2, 3, 4, 5, and 6, each say factor completely. And if at any point as you're doing that and you end up with something like this, where you still have a difference of squares, you have not factored completely. Okay, so that's something to know. On this, some good practice for this would be, say, oh, I had them. Where did I write these? So a good one to practice on, actually, we'll just do this one right here. So number 24 from page. This is number 4 on page 231. It is 2x to the 4th minus 32. Okay. Immediately, like the first thing I ask myself is like, well, okay, I see a difference. I'm wondering if this is a difference of squares. And I notice, oh, to the fourth power, that's good. There's an even power. We could probably rewrite this as a difference of squares. But that 2 is messing up my life right now. So it's
Pull it out, right?
squares. Say what?
You can pull it out, right?
I can pull it out. Okay. And so what do I have when I do that?
You have, so you have 2 on the outside and you have a parentheses x to the fourth minus 16.
Minus 16. Okay. So now, let's just continue. What do you want to do to this?
You can factor it out. So you have, well, 16 is the same as 2 to the fourth, right?
Yeah, 16 is 2 to the fourth. So I have x to the fourth minus 2 to the fourth. Okay. Now what?
You can make it into a difference of squares.
Yes. How?
You have x squared minus 2 squared.
There you go. Yeah. 2 squared squared. I like that.
And then you can have your x.
I'm gonna go ahead and jump to the chase. Okay.
Yeah.
What goes in here?
X goes there, and then you have,
What goes there?
wait, x squared.
X squared, and over here.
X squared,
Okay.
and then 2 squared.
I like that. And we could write it as 2 squared, or we could write it as 4 if we want. Oops. 2 squared. Okay. And then what?
Plus and minus.
Are we done?
No.
Nope. And so
Then you have,
let me write this, and I'm going to go ahead and write him as 4. Okay. Now what about over here? Now what?
then you have x, you get 2 parentheses.
2 parentheses.
Yeah. And then x on each side and 2 on each side, and plus and minus.
Plus and minus. Are we factored completely?
Hold on. X squared plus 4. Yes.
Yes. Yes, we are. That you can't pull anything out of x plus 2, and it is not a sum of, it is not a difference of squares. It is not a sum of cubes. This is not a difference of squares or sum or difference of cubes. That is a sum of squares. So he's done. 2's on the outside. We are completely factored right there. Now, as an aside, one thing you could do, if you wanted, is and if you're not comfortable with this, if you've been doing it this way for so long and you feel good about that, great. Another thing you could do is from right here, you know that this is a difference of squares because you know that's something to an even power, and you know that's something to an even power. And so it's kind of like I'm just kind of unfoiling here. I'm saying, well, what times itself gives me x to the fourth? Well, it has to be x squared. And so I'd do something like that. What times itself gives me 16? Well, that's a 4 and a 4. And since it's a difference of squares, I know I got to do that plus minus thing right there. And so right now we've already kind of jumped to the chase. We didn't need to go through these steps right here. You know, if you feel comfortable with that. The nice thing about this is, or about this method, is that you could just
Thank you. Coming.
You could stop and go, well, wait a minute, hold up. And like I do with every single step I take, I go, is this true? First, outer, inner, last. First gives me x to the fourth. Yes. outer, inner, cancel, because we have the minus 4x squared plus 4x squared gone. Positive 4, negative 4, down to 16. Yep, okay, we're good to go. And then from there, now we could go, well, wait a second. That guy is done. He is x squared plus 4. That is a sum of squares. You ain't pulling anything out of that. This is a difference of squares. And so I'm going to go ahead and prep him like that and say an x and an x. What times itself gives me 4? Well, 2. And since it's a difference of squares, I know it's a plus and a minus. But let's double check it. First outer inner last gives me x squared. Yes. Outer inner cancel. That's why I put the plus minus. Positive negative gives me a negative. 2 and 2 give me 4. Okay, I'm good to go. That's honestly how I go about doing these. But this is very nice because it takes the guesswork out of it. And if, can I erase this stuff?
Yes.
If this method that the way that we first did it is really nice if you're given, oh, I don't know, something like, I don't want to give you the actual one. Give me a second. Yeah. Yeah, we could do that. Let's just do it that way. So if that were to show up, doing it the way that we were thinking, we're like, oh, if I need to write that as a square, I could rewrite that as what squared?
4x squared.
4x squared. Squared is that, and I could double check that because in my brain I just say, wait a second, 4x squared, and this is what my brain, this is what I see in my head. It's like something squared means to take it, multiply it by itself. The 4 and the 4 come together to give me the 16. Yep. X squared and x squared come together to give me x to the 4th. Yep. So that is equal to that. Cool. And so we could do that. That would work. That would be nice to be able to do. You might see something that looks very familiar. Something very similar in the near future. You might have something like that. Okay. Okay, so I guess I'm really beating home the point. To factor something completely, we need to kind of stop and say, hold up, do I have any differences of squares? Do I have any sums of cubes? Do I have something like that? Like as we go along the way, when you have your answer and you go, ah, I'm done. Wait a second, is there a difference of squares in there? Okay, so sums and differences of cubes, differences of squares. Factor by grouping. So number 33 from page 231 was a really good one to practice for this quiz. Another good one to practice for this quiz will be number 34. Since it's an even one, let's just go ahead and do it. It is 3x cubed plus 6x squared minus 27x minus 54. We want to factor this. Like this is what's given. And let's say that I were to say factor completely. Well, first thing I notice is this is not a quadratic. In fact, this has an odd power in it. So I'm thinking I'm gonna have to factor this guy by grouping. In fact, that's the only way I know how to factor something by grouping. I mean, to factor something with an x third term. So anytime I see, well, anytime I see an odd power that's not a sum or difference of cubes. So for instance, 27x cubed plus another cube How about 8y cubed? I would immediately recognize, oh, that's a sum of cubes. I know what to do with that, right? Because that's a cube and that's a cube. And I could say, I could rewrite this as what?
9x. No. Sorry. 3x cubed.
3x quantity cubed. And then
2x cubed.
how about 2y?
2, right.
Right.
Yeah.
Right. So when I see that, I can immediately go, hold up. That's a cube. That's a cube. Now, I saw something like this. Give me just a second. Gotta do some math, and I can't do it in my head. Yeah. Ooh, there you go. I had this though.
Hello, baby.
I'd look at that and I'd be like, man, that's not a sum of cubes because that's not a cube. I don't need to use my brain for that. That might be a cube. I'm not too sure because it has a bunch of 2's in it. Maybe there's a total of 3 of them, but that's certainly not a cube. So, man, I don't know what to do. Maybe, is there something perhaps we could factor out? What might we be able to factor out of each one of those?
Yes. Yes.
Peter says yes. Don't use your brain. Look at the last
take a
number.
2.
They're each 2 digits, right? The last one's even. And so we could, what did you say?
A 2.
We could pull out a 2. And so I like to write it like this. I pulled out a 2. What would be left right here?
27x cubed.
Say what?
27.
27x cubed. And
8y cubed.
8y cubed, which is what I just did. What I did over here is I wrote 27 plus 27 because I couldn't multiply 27 times 2 in my head. I was like, what's 2 times 27? So the idea is, okay, I recognize this as a sum of cubes. And so I could rewrite this just like you said as 3x quantity cubed plus 2y quantity cubed, and then just use my nifty formula to factor this guy out. This guy, I don't recognize him as a cube. I do not recognize him as a cube. So maybe there's some common factor we could pull out to do that. And hey, look, sure enough, there was, right? So that's something. But when you are not in this situation, you have something like this. This is not a sum of cubes. The only way, a sum or a difference of cubes. The only way that I know how to deal with something like this is to factor by grouping. And so, please walk me through this. What would you like to do first to factor this guy?
Why?
A bunch of different ways we could go. And just throw anything out that you think.
You can take out a 3.
Yeah, we can. And what's funny is that's not what I would do first, but I'm not right. There's, like I said, there's a bunch of different ways you could do this. This way will work just fine. And in fact, it is the way that we've been doing stuff. So we should do it that way. Okay, so what's left from here?
2x squared.
Plus 2x squared. What's left from here?
Minus 9x.
Minus 9x. And then what about that guy?
Minus 18. Is it?
Is it 18?
I
I don't know. Let's see. 18 times.
think it's 18.
8 times 3 is 4 and a 2 and a 3 and 8, 54. Wow, good. I see. I don't know that one. And that's probably why I wouldn't have done that. But you're absolutely right. Yeah, good. Excellent. Okay, now what do you want to do?
Yeah.
Yeah. Yeah. And so this is where this is at this point, right? Like if I wasn't given this, if I just said factor this, I would think, yikes, there's a cube in there. It's not a sum of cubes, it's not a difference of cubes. So I'm gonna have to group.
You could do I think you could do x cubed minus 9x, but that would be 2x cubed, right? No.
So
no, never mind.
well, there, you know what's funny? So what you're describing will get you to where we're going. What I notice right away, the way I like to do it, is I group this way. I say, well, let's start off. We might have to do some rearranging and maybe that'll make my life easier. But just starting off, is there a common factor in these two, with these two?
Yes.
What do I do?
You take the x out, so you have x plus 2x. Or you can take 2 x's out actually.
There you go. We could take
X squared, and then you have x plus 2.
Now I've just written that. I'm going to double check it and say, okay, throw in the x squared gives me x cubed. Throw in the x squared gives me 2x squared. Cool. What about this guy?
You can take out a 9.
I could take out a 9.
But no.
Well, yeah, but how about this? And this is what I'm looking ahead for. This is a x plus a 2. If I take out a 9, I'll have an x minus something. I notice that both of these are negative. So why don't I take out the negative 9?
Okay.
And so this is why I really wanted to do this one right here, because it does have a negative and a negative. And that's usually how I think about it. So if I take out a negative 9, what's left over?
X. No. Sorry. Plus 2.
Plus 2. And then I'm going to double check it. I'm gonna double check it and say, okay, negative 9 jumps back in to give me a negative 9x. Yes. Negative 9 jumps in to give me a negative 18. Yes. Now I could see, look at that. I have a common factor that I could pull out. So you tell me what to write. I'm going to go ahead and start it off for you. The 3's coming along for the ride. What are we pulling out?
Well, can't you do x squared minus 9 and x plus 2 squared? No. No. Wait.
So now we're at this point. Let's use that what we did earlier and just kind of think about this. Remember earlier when I said, well, this and this are the same thing. What if I just called it OA minus 9 times A? Is there a common factor there that I could pull out?
Yes, you can pull out the x plus 2.
Yeah, and so in this case, right, and then this is just what goes through my brain. Like I kind of see this as like, well, if that was just a number, in fact, if that were a 7, and if that were a 7, I could pull out 1 7. And so this is kind of what my brain sees. And I think, I would pull out that 7 like that, leaving me that right there. And so, okay, so what do I have here?
You have a 3 times x plus 2.
Yep.
And then x squared minus 9.
Okay, now let's double check. All we did is we took that one term, pulled him out. And so if we throw him back in, he jumps over the parentheses, hits the x squared to give me x squared times x plus 2. Then he jumps over the minus to give me 9 times x squared plus 2, which is what we had to begin with. Are we factored completely?
No.
No, good, excellent. This is going to be this is going to be very familiar. Like you, in fact, man, on Friday you're going to be like, "Whoa, I remember this almost exactly." You get to this point, and you're not done. What do we have to do?
You have to factor out the x squared minus 9. So 3x plus 2, and then you have x plus 3 minus x, times x minus 3.
There we go, right? And you'll notice, because at this point you should be really familiar with differences of squares, that not every time, you shouldn't every time have to go through this step right there, right? Because in your head, you could just say, well, that is something times itself, and I know what that thing is, it's a 3, right? Although when they're more complicated, like when you have something raised to the 4th power, it is helpful to rewrite it in this form first. But in this case, just like you didn't have to do this, and you just jumped right to the chase and said, well, that is that. I know, because 3 times 3 is 9, and that guy right there, the outer and the inner, and it's what I'm doing as I write this down. I'm going to stop and double check and go, wait, first, outer, inner, last. First gives me x squared, outer is minus 3x, inner is plus 3x, they cancel. Positive 3 and negative 3 do give me a 9, so that is the same thing as that. I feel confident about that. I'm going to move along. Are we completely factored?
Yes.
We are factored completely. I'm going to put a box around it right there. That is my final answer. And yeah, I had not gone, I had already written up the quiz and written up the solutions and stuff like that. And then it was this morning I looked at problem 34 and went, oh, that's very similar to something that's on your quiz. Very similar. So if you can follow along with this. Yeah. So, okay. So more factoring. You had better be able to factor a quadratic, right? Something in the form. Something in this form, ax squared plus bx plus c. If you see something like that, you should be able to break this down into that. That's also one thing. 2 more things I want to talk about before we are done. Like I said, when you're taking a quiz, all reason and logic just go out of your brain, and you start to like doubt yourself and stuff like that. And on 5 of the questions, I say factor completely. And that could really mess with your brain, especially with sums and differences of cubes. And so I want to go ahead and take care of something right now that I think in the last lecture, or maybe the one before, I said, well, it may be this way or that way. We're going to go ahead and just knock this out right now. When you have a sum or a difference of cubes, let's just do a sum of cubes. We know that, we have a sum of cubes. There's a nifty little formula. And so whatever that is to its original power, or to no power, which is the power of 1. And then we go, yep, a squared, and then a b, and then b squared. And then for the signs, we go SOAP, right? The same, opposite, always positive, same, opposite, always positive. So you're going along and you're doing your quiz and you end up with this right here. And then you wonder, am I done factoring? Can this be factored anymore? Oh man, and then you waste about 20 minutes trying to factor something like this. I'm gonna go ahead and tell you, don't. When you get to this point, you are done. This cannot be factored anymore. let's prove that fact right now. Suppose that this can be factored. Okay, let's suppose that it can. Well, what's it going to have to look like? Well, something like this. Okay. Well, what has to go in the first? Because remember, first, outer, inner, last, what would have to go here and here? Okay. For the last, right? First, outer, inner, last, what would have to go here?
B.
B. Okay. Okay, so now remember, we're wondering, is it possible? We don't know yet. We're assuming it is possible to factor this guy further. Well, let's see. It would have to have this form because the only way you can get a pure A is if you have an A and an A, okay? The only way you can get a pure B is if you have a B and a B. It has to be this way. So now let's just look and see. First gives me A squared. The outer gives me what?
AB.
The inner gives me
AB.
AB. And the last gives me
B squared.
B squared. And now the question is there any way to add or subtract these guys to give me just 1 minus AB?
No.
No, because if it's plus and plus, we'll have 2AB. If it's minus and minus, we'll have minus 2AB. If it's a plus and a minus, we get a 0. If it's a minus and a plus, we get a 0. So there's no way to put anything in here, plus, minus, or otherwise, in order to give me just 1 minus AB. So this thing is factored as much as it possibly can be factored. There's no way to factor it further. The same thing's true if we had a minus. That would change this sign to a minus because same, opposite, always positive. And now we're wondering, well, you're doing this type of thing. Is there any way to get 1 positive AB? Well, no, the only possibilities are a positive 2AB, a minus 2AB, a 0 or a 0. You can't get just 1 plus AB out of this. And so no, our question is this factorable anymore? No, it's not. It is not equal to any kind of factorization like this. It might be the case that there's a common factor, like there might be a 3 here and a 3 here and a 3 here when you're all done. And that just means that you didn't like factor that 3 out to begin with. Like if you started off with an 8x cubed minus 8y cubed, and you didn't bother to factor out that 8 in the beginning, and you said, well, this is the same thing as 2x cubed minus 2y cubed, and so you just blindly put them in and said, okay, then that's a 2x and a 2y, and then you have a 2x quantity squared and a 2x and a 2y and a 2y quantity squared, and then you did your signs and you said same, opposite, always positive, and then you'd have, okay, 2x minus 2y, and then you'd have a 4x squared plus 4xy plus 4y squared. You'll notice, oh, hey, you can actually factor some stuff out. Like at this point, you wouldn't be done. You'd have to factor out a 2 from here. So you'd have a 2 that comes right here. And it looks like you could factor out a 4 from here. So we'd have a 4 that comes out of here. In which case, pull that all together and you would have an 8x minus y times x squared plus xy plus y squared. But that's exactly what you would get if in the very beginning you said, well, wait a second, I have a common factor here. And I could have pulled it out at the very beginning to give me 8 times the x cubed minus y cubed. And then I would have this right here. Either way, you've done it. So the takeaway point is this, like, yeah, if you don't have a common factor in every single one of these, like that might happen. You might end up with that. And then yes, you could pull it out. But if that's not the case, there is no way to factor this guy further. I don't want you to try to waste your time thinking, am I completely factored? Oh no, it says factor completely. I better really work on this. No, you don't need to. It's done. Like when you get to this point right here, even if it looks funky, even if there are some numbers in there, like if that happens to be an X and a 4 and oh, I don't know, like a 2 or something like that. Well, there's not a common factor in every one of those. You can't pull out it's like, oh, there's a 4 and a 2. Can I? Well, no, there's not a 2 there. There's not a 4 there. You're done. You are done. Don't worry about it anymore. Am I clear? Have I made my point?
Yes.
Okay, cool. So the last thing I want to talk about. So problems 1 through 6 are exactly things you've seen before. They're basically from your homework. I've just changed some numbers around. Problem 7 is a doozy. Problem 7 is not friendly, but with this hint that I'm about to give you right now, it should be possibly the easiest problem on there. So I'm really going to show my hand here. I'm basically going to give it away, but not quite. But let's just do this. Let's say that I gave you something like this. Let's say I said that let g of x equal, oh, I don't know, how about 7 over, let's go 2x plus 1. If I said, write the domain of G in interval notation, describe to me what you would do. Let's work this out together. You tell me, what's the first thing you would do?
I would put in 0 for x, maybe.
You would plug in a 0 for x. So
You
you
could still do that. So that means that 7. Okay. I don't know.
okay. What is a domain?
All of the inputs
Not
in a function.
Yeah, they are the
All of the given. Wait.
how about the way I like to say it is the allowable.
Yes.
The allowable input.
Mm-hmm.
What's the only problem we might have with this type of thing? In fact, what's the only thing that we can't do? There's one operation really that we can never do. What is
Can't
that?
divide by 0.
Can't divide by 0. And so the denominator of this cannot be what?
0.
The denominator cannot be 0. So how can we find what inputs would give us 0? What would you do?
Would we set the bottom or the denominator equal to 0?
Yes, exactly. So let's think this through. Well, I just said we want to write the domain of G in interval notation. And so I think, okay, what are all the allowable inputs? And so I look at the actual function that's given and I say, well, There's no problems with plugging in, say, 0 or something like that. But there's one thing I can't do, and that is that this thing, that thing right there, whatever is in the denominator, cannot equal 0. So I just kind of think, okay, then whatever that is, when that thing is equal to 0, and that's, what you basically, I'm just really driving the point home, but this is what you just told me to do. You said, we're going to take whatever's in the denominator, we're going to set it equal to 0, and then we'll know what values we cannot plug in. So keep talking to me. What do I do now?
You subtract 1 from both sides
Subtract 1 from
and then divide by 2.
Then I divide by 2 and
And x equals -1.
Okay, so now we have found that we cannot have this. As a matter of fact, we just said that, and I'm gonna just double check, right? I'm gonna see what happens if I do plug it in. If I try to plug in -1/2, I would have, I would have 7 over 2 times -1/2 plus 1, which is 7 over the 2 kills the 2, and I have -1 plus 1. That gives me 7 over 0. Uh-oh, you cannot do that. That's bad. You cannot have division by 0. So we have found the one value that we cannot plug into this function. Are there any other problems? Can I plug any other number into G?
Yes.
Yeah, yes, we can. Because there's only one number. There's only in this case, let those who have ears, with those who have ears, let them hear. In this case, there's only one number that I cannot plug in. And so now I could say, okay, so this is the one number I cannot have. All the other numbers work, right? So how do I write that in interval notation?
You have a hard bracket, right?
I have a hard bracket.
And then negative infinity. Am I doing this wrong?
You are. We never have a hard bracket for we never include infinity.
Wait, but I thought that's how we wrote it.
Soft bracket for infinity. Always.
Ooh.
Always, always. Look back over quiz 0 and quiz 0.1 if you don't remember.
Okay.
I have oodles of pictures of your handwriting that you have taken for me.
Yes, I forgot.
They all are like this. We never include infinity because infinity is not a number. It's constant. Okay. And so, you're telling me we have
a soft bracket.
Mm-hmm.
Negative infinity.
Yep.
Comma. -1/2.
Yep.
Soft bracket.
Yep.
And then you do that U symbol, right?
Union. Yep.
And then you have a soft bracket.
Yep.
-1/2.
Yep.
Comma infinity.
Up to infinity.
Soft bracket.
And so we could say, so finally, here we go. So now, what I like to do, the way I like to do this is visually, I think this would be all real numbers. And so this is kind of what I start with for all of these guys, right? And I just think, okay, potentially all real numbers are inputs. As far as I'm concerned, when I first begin this problem, all real numbers are possible inputs. And then I think, well, wait a minute, we just found that x cannot equal -1/2. And so I just imagine, okay, then I have to pull out -1/2. What does that leave me? Well, it leaves me this part here and this part here. And so now I have those two intervals, and I have them from -infinity up to -1/2. And then I'm going to take the ones past -1/2 all the way up to infinity, union those guys together. And yes, of course, it means exactly the same thing. Okay, and so finally, I would say, yeah, the domain of G, and you don't need, you could just write it like this, but if you want to be really cool, you could say the domain of G is equal to this right here. And you would be right. And I would say, yeah, let's just think about this. This means that you could plug in every real number except for that one that you pulled out, which is -1/2. Why can't you plug in -1/2? Because if you tried, you would have a -1/2 right there. The 2 would kill the 2, and you'd have a -1 plus 1 would give you a 0 in the denominator. You cannot have a 0 in the denominator. Real quick. I have really showed my hand right there. Like the hardest problem on the quiz is pretty much the only thing really is, let's suppose, oh, I don't know, that we found that there were actually two numbers that you could have. Let's say that we did something and somehow we found that x could not equal 1/2 and that x could not equal, say, 3. We'd have to pull out another number, right? In which case, what would I be left with? In fact, just go ahead and tell me the whole interval if we had to also pull out a 3.
Soft bracket, -infinity, comma, -1/2,
Yep.
and then the union,
Yep.
I think. And then you have the soft bracket, -1/2, 3.
Up to 3, because that's what I'm thinking about like this. Is like we also have to pull out a 3. And so that leaves me what?
Soft bracket.
Soft bracket, because we are not including 3. 3 has to be excluded. And so then we move beyond 3 and then what?
Union, soft bracket,
Yep.
3, comma, infinity, soft bracket.
There we go. And that's what I would do. I would say, because this is the visual I have in my head, as I take potentially I have all real numbers. I can plug them into my function, then I find, oh, nope, there's two numbers where you can't. And so we'd have to pull that guy out and pull that guy out. And this is what I have visually. Then when I go to write it down, I say, well, yeah, all the real numbers up to -1/2, not including -1/2. Then we could have all the ones bigger than 1/2, but not including, and so on and so forth. And then I'd say that is my domain.